All right, so I am going to be going through a review of stoichiometry. Uh, I'm going to do three examples that come directly from your handout, and then the rest, hopefully, you will be able to finish on your own. So if you look at question number 2, um, it says how many moles of O2 can be produced by reacting 12.0 moles of KClO3. All right, so on your handout, I put a little MR, meaning that we need to find the mole ratio in this question. If you notice, they don't mention grams and they don't mention mass anywhere, so we only need to know moles. Our two different compounds that they mention are O2, so on the top I'm going to put moles of O2, and the second compound is KClO3, so I'm going to put moles of KClO3. If we look at our balanced equation, the coefficient for O2 is 3, which means there are 3 moles of O2, and the coefficient for KClO3 is 2. So our mole ratio, 3 moles of oxygen, O2, to 2 moles of KClO3. Now we're ready to set up our train tracks. In our first box, we always put what is given in the problem. Our problem says that we're starting with 12 moles. So I'm going to put 12.0 moles of KClO3. Remember, the whole point of the tracks is to cancel out our units. So whatever unit is in your top box, you can immediately put that same unit in the bottom box. So I'm going to copy moles of KClO3. Now, we only have the mole ratio for this problem, so we don't need to worry about what do we need to plug in. Or we don't need to figure out, are we using the mole ratio? Are we using the molar mass? If we look over here, we have 2 moles with KClO3, so we're going to put a 2 with that. And it doesn't matter what's in the top or bottom when we're plugging in, because this ratio is always equal. We could have put 2 moles of KClO3 in the top and 3 moles of O2 in the bottom. It doesn't matter what's on the top and bottom as long as that ratio stays in the same section of our tracks. But here it works out perfectly because on the top we're going to put 3 moles of O2. Our question is asking us how many moles of O2, so we're at the unit that we want. Our moles of KClO3 cancel out. So we multiply on the top, 12 times 3 gives us 36 moles of O2, and on the bottom we just have a 2. 36 divided by 2 gives us 18 moles of O2. So this was just a one-step problem, not involving mass, just using the mole ratio. Moving on to question number 3, there are 2 parts to question number 3. I'm actually going to be doing the second part, where it asks how many grams of KCl is produced from 106 grams of Cl2. So this question is really nice because they actually already give you the molar mass of KCl. So I'm just going to fill that in on the side. Molar mass equals 74.55 grams of KCl over 1 mole of KCl. And again, our grams per mole we can write as grams over moles just to make it easier to plug into our train tracks. They do not give us the molar mass of Cl2, so we're going to calculate that really quickly. Thankfully, it's easy. We have 2 Cls. Each one has a mass of 35. That gives us 70 grams of Cl2 over 1 mole. Since they are asking us to convert all the way from grams of one substance to grams of another, we need the mole ratio. And again, the mole ratio is going to be used whenever you are changing from one substance to the next. The mole ratio is the only way in our conversions that we can switch from one compound to a new compound. So our first compound, and again, it doesn't matter which one you put on the top or bottom. I'm going to put KCl. You could easily put Cl2. Doesn't matter at all. If we look at our balanced equation, at KCl, it has a coefficient of 2. And for Cl2, There's nothing in front of it, so we know that that coefficient is 1 holding its place, so we can put in a 1 there. Setting up our train tracks, they give us 106 grams of Cl2 to start, so that goes in our first box. Whatever unit is in the top, we can put that same unit in the bottom, grams of Cl2. If we look over on the side, we have grams of Cl2 in our molar mass. A 70, oh, I forgot the Cl2 there. 70 goes with grams of Cl2, and whatever is connected with that ratio, the other half of it has to go above it. So we've got to put 1 mole of Cl2 in the top. Our molar mass has been used, so it's done. Our grams of Cl2 cancel out, and we're left with moles. We're looking for grams of KCl, so we've got to keep going. Whatever unit is in the top, that same unit goes in the bottom. So we need moles of Cl2. We have it with our mole ratio. We see that a 1 goes with moles of Cl2. The other part of that ratio is moles of KCl. So we're going to put 2 moles of KCl in the top. Our moles of Cl2 cancel out. They're asking us for grams of KCl, so we're still not quite there. The unit that we're getting rid of goes in the bottom, moles of KCl. We used our mole ratio, so that means we only have the molar mass of KCl left. I see that there is a 1 with our moles, and in the top we are going to put 74.55 grams of KCl. Grams of KCl is what we're looking for, so we know that we've set our train tracks up correctly. Now we're ready to multiply on the top. 106 times 1 times 2 times 74.55. That will give us 15,804.6 grams of KCl. And on the bottom, 70 times 1 times 1 gives us 70. We divide, and that will give us a final answer of 225.8 grams of KCl. Again, when we're going from grams to grams, that's going to be the longest conversion that you're going to have. We're going to do one more example together, and then you're going to finish the rest of the problems on your own. We're going to move on to question number 4. And again, it is a 2-part question, but we are going to be doing the second part. This one is a little interesting. It's in between just converting from moles to moles and grams to grams. We're actually going from grams to moles, so it's a little bit shorter. If we look at this, they give us the molar mass of NaOH, so we don't have to calculate that. I'm just going to write it to the side. Our molar mass equals 40.00 grams of NaOH over 1 mole of NaOH. And since they are asking us to convert from NaOH to Na2O, that means we're going to need the mole ratio. Again, whenever you're going from one compound to the next, you need the mole ratio. I'm going to put NaOH on top. Again, it doesn't matter at all. You could put Na2O on the top as well. If we look at our balanced equation, NaOH has a coefficient of 2, and Na2O does not have a coefficient, so we know that there is a 1 there holding its place. We don't need to calculate the molar mass of Na2O because they're just asking for moles. If they were asking for grams, we would need that molar mass, but since they're not, we won't bother finding it. We start with our given amount, 160 grams of NaOH. Whatever unit is in the top, we can put that same unit in the bottom. If we look over at the side at our molar mass, we see that 40 goes with grams of NaOH, and the other part of that ratio is 1 mole, which we will put in the top. Our grams cancel out since we have it on the top and bottom. We're at moles of NaOH, but the problem is asking for moles of Na2O. So we've got to do another step. Whatever unit we're trying to cancel out, just carry it down to the bottom, moles of NaOH. We already used our molar mass, so that's gone, which means we only have the mole ratio left to use. I see that there is a 2 with our moles of NaOH, and the other part of our ratio has to go in the top. 1 mole